All right, so to the actual remainder theorem. When we try to divide by something that does not have a corresponding root, we're going to get a remainder. So we're going to do the same thing, or use the same polynomial, the 6x cubed minus 5x squared minus 19x plus 10, but we're going to divide it by x minus 3, which was not, we didn't pass through 3 when we looked at our graph, so we're going to see what happens here. So our factor of x minus 3, 6x to the third, and then we're going to factor that out. So we've got 6x squared here. Then we multiply to get negative 18x squared. To get from negative 18x to negative 5x squared, we have to add 13x squared. Factor out a 13x. Multiply to give us negative 39x. We have to add 20x to get to negative 19x. So that's 20. And then we multiply to get negative 60. Now, that's not what our last thing is. So from here, we'll have to figure out the remainder. So we're going to come back to this. I'm going to star that because we're going to come back to this after we do the long division and the synthetic division. Okay, so to the long division. We're going to start up here. We multiply 6x squared by the x to get 6x to the third. So now we multiply out. 6x squared times x gives us 6x to the third. 6x squared times negative 3 gives us negative 18x squared. Then we subtract. Negative 5x squared minus a negative 18x squared is the same as negative 5x squared plus 18x squared, 13x squared. X goes into 13x squared. Oh, sorry, I'm going to drop down my negative 19x. X goes into 13x squared, 13x times, if we want to put it that way. Then we multiply 13x squared minus 39x, 13x times negative 3.
So we need to make it 20.
Mathematically, we're doing the same thing that we just did.
But, so the reason it's 39 is to make it 20, right?
Well, the reason it's 39 is because 13x times negative 3. So then this double negative means we're adding again. So negative 19x plus 39x gives us 20x. We're going to drop down plus 10. X goes into 20x 20 times. So plus 20. 20 times x gives me 20x. 20 times negative 3 gives me negative 60. Going to subtract again. This is why I don't prefer this method, because the double negative, sometimes people forget to subtract. So 10 plus 60 gives me 70. So that means I have 6x squared plus 13x plus 20 with a remainder of 70.
That sounds very right.
Yeah, it's lovely. If you want to.
Can we put a star around it?
So, what I want to talk about real quick, this thing that I started up here, we ended up here in our last box with negative 60. We needed that to be negative 10, so we know x minus 3 isn't a factor. Down here we got a remainder of 70. So if you look at this, that remainder of 70, if we add that 70 to that negative 60, we get that 10. We need it to be positive 10. Did I say negative 10?
Jeez, Miss Adams, bitch.
I meant negative, or I meant positive 10.
shame.
Oh, shut up.
Twice in a row.
Alright, so now synthetic division. So the thing to remember with synthetic division is you use the root, not the factor. The root that we're saying corresponds to the factor of x minus 3 is just 3. And then we put in our coefficients. 6, negative 5, negative 19, and 10. So what do we do first?
So you multiply 3, bring the 6 down and multiply it by 3.
Bring the 6 down, multiply it by 3 to get 18. Negative 5 plus 18 is 13. 3 times 13 is 39. Negative 19 plus 39 is 20. 3 times 20 is 60. With a remainder of 70. I know. So, if we decide that we want to write this in some type of factored form, which isn't going to help us a whole lot, we have x minus 3 times 6x squared plus 13x plus 20 plus our remainder of 70. That is an equivalent, though not terribly helpful, way of writing that f of x. Which I forgot. Hang on just a second. I forgot that's below. So, okay. So, this brings us to the important part of the remainder theorem, which can be written as, so what we just wrote above, which is the x minus 3, no, sorry, not the x minus 3, because this is dividing. So we divided this polynomial by x minus 3 and ended up with 6x squared plus 13x plus 20 plus our remainder of 70. So, okay. So, if we rewrite this, we have that 6x squared. We already wrote this above, but we'll do it again. Plus 13x plus 20 times x minus 3 with our remainder plus 70. Now, I'm not going to plug this in twice. I'm just going to do it once. The remainder theorem tells us that if we evaluate a polynomial for a certain value, that's going to give us the remainder if it's not divisible. So, I'll talk about that in a minute. So, I'm going to take my original polynomial, and I'm going to plug in 3 for x. So, 6 times 3 to the third minus 5 times 3 squared minus 19 times 3 plus 10. And since I have no room, I'm just going to plug all that into the calculator. It should give you your remainder. So, if that part that we were dividing by, we divided by that 3, or we divided it by x minus 3, we ended up with a remainder of 7. If we plug f of 3, so if we plug 3 into our polynomial, we should get that remainder.
Is that just how you check that you got the right remainder?
Yes, that's how you check that you got the right remainder, and that is the whole of the remainder theorem.
Does that mean that if you find 3 from that, you have to make them equal to 6?
So if we try that with f of 2, we get 6 times 2 squared minus 5 times 2 squared minus 19 19 times 2 plus 10.
This is so much easier than all of these, right? Can we do this?
So I guess actually, Elsa, as to your question as to when this is a useful thing to have, it's a good way to determine without a calculator or Desmos if something is a factor of a polynomial. Because if you get 0 when you plug it in, then it's a factor. If it's not, you get a remainder. Uh-oh. I plugged in something wrong.
It was the square.
There we go. So we factored that, or we divided x minus 2 on the front side, and we got no remainder. So if we plug in x, or 2 for x, into that polynomial, we again get no remainder. So that is the remainder theorem. As I mentioned before, considering that the highly proficient level for factoring higher degree polynomials. So what we did on the front side with the box, that's proficiency level. What we did with the long division and synthetic division and how you relate that to the remainder theorem is going to be considered the highly proficient level. The end.